Okay, this is constant pressure. What is constant pressure? Constant pressure occurs at when the pressure is constant along the process. So if we can see here, this is PV diagram. Okay, as pressure increase, we can see that the pressure is constant. An isobaric expansion of gas, it requires heat transfer to keep the pressure constant. Okay, this is isobaric process. The boundary work for isobaric process, we still use this equation. WB is integration from point 1 to point 2 P dV. Since P is constant, therefore we put this P outside the integration and we will only integrate dV. Therefore, the equation will become P V2 minus V1. V is volume in meter cube. And next, we go to first law of thermodynamic of closed system. This is first law of thermodynamic of closed system. Q minus W is equal to delta U. For isobaric process, there is a work. Please don't get confused with isochoric. In isochoric, there is no work. In isobaric, there is work. Therefore, we have to measure or we have to calculate work. Okay, let me show you. Alright, Q is equal to delta U plus W. If you still remember this equation, U plus W is also equal to PV, right? U let me start again. Okay, U plus W. So, U plus W is equal to PV. If you still remember, U plus PV is enthalpy. Okay, so we replace U plus W. Since this is a capital word, therefore H will in capital word. So Q is equal to delta H, enthalpy. Again, if the substance of the process is liquid, therefore we have to find H from property table. Okay, and if the substance is in gas, then we have to find enthalpy from this equation, mass multiplied with Cp, specific heat for gas pressure, specific for pressure constant, multiplied with the differences of temperature. Q is equal to mCp T2 minus T1 in kilojoule. But if want to find Q in small letter, Q is equal to Cp delta T. And the unit is kilojoule over kilogram. Okay? So can I proceed? Okay, so example 5, we already solved it in our previous